Hello students, in this video I will go through exercise U5A07B where I will be applying concepts related to trig function identities. Let's take a look. Alright, so these questions are taken right out of the geometry regions from past years ranging from 2014 all the way to 2019. And what we're going to do is just take a look at some of these examples because I was unable to locate some of these types of questions in our class texts or in any of the software that I use to generate problems. So these are very, very region specific. Let's take a look. All right, so explain why cosine of x is equal to sine of 90 minus x for x such that x is between 0 and 90. Well, this is what they're asking you to do, is explain why that identity is true. And the identity is true because, let's say if I create a triangle here, let's call this x, y, and z. So cosine of x is equivalent to, this is lowercase x, this is lowercase y, and this is lowercase z, will be equivalent to y over z. And if I do sine of y, that will be equivalent to what? Lowercase y over lowercase z. And if you haven't noticed, they're equivalent. And what's the relationship between y and x? Well, y and x are complementary. So therefore, x is equivalent to, or y is equivalent to 90 minus x. So if y is equivalent to 90 minus x, then I can then make that substitution. And I can say cosine of x is equivalent to sine of 90 minus x. And that's it. All right. Question number 9, taken out of August 2015. In triangle ABC, the complement of angle B is angle A. So in other words, angle A plus angle B is equal to 90 degrees. That's what it means for two things to be complementary. Which statement is always true? Well, as I've just demonstrated over here, x and 90 minus x, they are complementary, just as x and y are complementary. So sine of A must equal to cosine of B. And we have anything like that? So it's not this, it's not that, it's not this. It's this guy. Okay. January 2016, in triangle ABC, the complement of angle B is angle A. The complement of angle B is angle A. Essentially, it's the same question. If you notice that August 2015 and January 2016, both of which were question 9, they are essentially the same question. Which statement is always true? So it's, again, option 4. It's the same exact question, which is, you know, quite reasonable for regions, for the regions. Again, this is just to show you that if you do enough of them, you know, you're going to get good at it and then you're going to do really, really, really well on it. Okay, August 2016, question 6. Triangle ABC, where angle C is a right angle, cosine of A is equal to square root of 21 over 5. What is sine of B? So, angle C is a right angle. Why is that important? Well, that's because if C is a right angle, that means this has to be A and that has to be B, or it could be the other way around. It really doesn't matter. But the point is this: A plus B is equal to 90. And if that's the case, cosine of A should equal to sine of 90 minus A. And what is 90 minus A? Well, that's 90 minus A is B, right? So in other words, sine of B is equal to the same thing, square root of 21 over 5. It's option 1. Okay. In right triangle ABC, angle C is equal to 90 degrees. Cosine of B is equal to 5/13. This is very similar. Again, it's essentially the same question, but just different numbers. Can you compare and contrast August 2016 with that of June 2017? Right? Compare and contrast. Right? So cosine of B is 5/13, so therefore sine of A must be 5/13. Right? Which function also equals to 5/13? Sine of A. August 2017, in a right triangle, sine of 40 minus x is equal to cosine of 3x. What is the value of x? Now, in order for this identity to be true, these angles here must be complementary. So if I call this A and if I call that B, A plus B must equal to 90 degrees, right? That's the identity. So if I say 40 minus x plus 3x, that must be equivalent to 90 degrees. Combining like terms, I get 40 plus 2x is equal to 90. Subtract 40, 2x is equal to 50. Divide by 2, x is equal to 25. And that would be option 4. All right, June 2018. In a right triangle, the acute angles have the relationship sine of 2x plus 4 is equivalent to cosine of 46. What is the value of x? And again, August 2017 and June of 2018, essentially the same question. So 2x plus 4 plus 46, those two angles are complementary, so it's equivalent to 90. Let's combine like terms. 2x plus 50 is equal to 90. Subtract 50, 2x is equal to 40. Divide by 2, x is equal to 20. June 2019, the expression tangent of 57 is equal to. So tangent of 57, I'm sorry, not tangent, where am I getting tangent from? That's sine. So sine of 57 should be equivalent to cosine of what angle? Again, that angle has to be complementary, right? So 57 plus that should equal to 90. That should equal to 33. So cosine of 33, in other words, and that would be option 2.